Hi guys, in this video we will discuss about the surprise structures that wrapped around the Earth's core. Okay, let's start this video. Blobs of hot, dense material that curl around the Earth's core are much more widespread than previous research suggested by the scientists. A new method of analyzing the earthquakes data has found even more of the previously detected continent-sized zones at the boundary between the planet's core and mantle. We still don't know what these blobs are. They could be magma or molten iron or leaking from the core or something else. But with a more complete and detailed map of where they are, we can better understand the geological process occurring deep inside the Earth's interior. The core boundary lies some 2900 kilometers, that means 1800 miles, below Earth's surface. That extremely out of reach. So, if you want to know what conditions are like down there, we have to get creative. Luckily, Earth comes with a built-in tool for probing, that is, earthquakes. The way quakes and tremors propagate through different kind of material inside the planet has allowed seismologists to reconstruct and map the composition of Earth's interior. This is how vast blobs of superhot material were identified at the core mantle boundary decades ago. Because the heat causes greater degrees of melting, the zone's slow velocity of the earthquake waves right down. So they are known as the ultra low velocity zones. But earthquakes can be an unsatisfactory tool, providing only trickles of information at a time. We have to wait for earthquakes. Each earthquake only probes a narrow zone, and weaker signals can get lost in the border noise. To compensate for this problem, researchers from the University of Maryland, Johns and Hopkins University turned to an unusual source, the stars. Well, not actually the star, an algorithm for studying the stars. It's called the sequencer, and it's designed to run through large astronomical datasets looking for patterns. As it turns out, the algorithm can be tweaked to look at seismic data too, a lot of seismic data. The researchers fed it 30 years of data, around 700,000 seismograms of one particular type of seismic wave, looking for the seismic echoes indicating in the ultra low velocity zone that we have measured in previous analysis. And bingo, they got a hit. By looking at thousands of core mantle boundary echoes at once, instead of focusing on a few at a time, as it usually done, we have gotten a totally new perspective, set by a geologist at the University of Maryland. This is showing us that the core mantle boundary region has lots of structures that could produce these echoes, and that was something we didn't realize before because we only had a narrow view. The results resulted by the sequencer revealed that subtle changes in seismic waveforms from earthquakes in Asia and Oceania, suggesting a previously undetected ultra-low velocity zone beneath the Marquesas Islands in the South Pacific. We were surprised to find such a big feature beneath the Marquesas Islands that we didn't even know existed before, said by the geologist at the University of Maryland. This is really exciting because it shows how the sequencer algorithm can help us to conjugalize semis- seismogram data across the globe in a way we couldn't before. In addition, the known ultra-low velocity zone beneath Hawaii produced seismic echoes much louder than expected. This suggests that it is significantly larger than previous studies had estimated, and the overall findings suggest that Earth's guts are rather more blobby than we expected. We found echoes on about 40% of all seismic wave paths. That was surprising because we were expecting them to be more rare, and what that means is the Anomalous structures at the core mantle boundary are much more widespread than previously thought. Having demonstrated the sequencer efficiency, one type of wave, the terms techniques can now be applied to other types of waves and frequencies. This could help compile a new high resolution map of the Earth's interior. In turn, the physical properties this reveals could help geologists interfere the chemistry and temperature of the surfaces or structures, leading us closer to the solving the mystery of what causing these strange dense zones wrapped around the heat of Earth. Thank you. I hope you like this video. If you like this video, please like, share and subscribe. Thank you.